Hello YouTube, this is Ready Set Exploit, and we're going to be doing Eavesdropper from TryHackMe, which is a really fun room where we perform an attack called Sudo Hijacking. And basically it's very similar to PATH Hijacking, where if a user, preferably a higher level user or even our current user, is using a command without the full path being set, and we have a way to control where the path will be, we can have it execute our command instead. And I'll go into more detail about it. Basically, we're given access to an SSH server provided with the SSH keys as the user Frank. We see that Frank is executing the sudo command, and what we do is, because Frank is executing the sudo command without the full path being set, we can write our own sudo command and have that Frank user execute that command instead. And what we're going to do is, with that command, we're actually going to capture the password, because when you run sudo, you're prompted for a password, and with that password we can achieve root access because Frank is part of the sudo group. So without further ado, I'll go ahead and get started. You are provided with the SSH key, and as you can see, this is provided by the room. You can just download it, save it. You got to give it the appropriate permissions, chmod 600 IDRSA, and then we can go ahead and connect with SSH-I, select the key, username, add, and then the IP address you want to connect to. And if you get this prompt, just type yes, and we have access to the server, right? And I want to call this, and as you notice, I skipped the nmap because this room is pretty straightforward. It tells you what to do. You can do an nmap scan, but it's really not required. So we can call this SSH Frank 1. And I always like having another server. We could call this server. Now, there's really not a lot, right? So first thing I check, we could check our groups, and when I see them part of the sudo group, means if I can figure out Frank's password, I can achieve root access, right? We could do that with sudo su, but we need a password. We don't know it. We do sudo l. We need a password to see what we can execute, which will probably be everything because we're part of the sudo group. So can't do anything there. We could look for maybe any set UID binaries. Find dash permission. User has a set UID. Type F. Do some basic checks. See. Okay, there's really nothing, right? Sudo passwd. So nothing that really stands out. We could run LinPeas on it. And I'll actually run LinPeas later because, let's get our items in order. What I'm going to do is, first, the two items I always like to bring is Pspy. If you're not sure, if you don't have that tool, just Google Pspy, GitHub, and there's this one, Dominic Brucker. Just go to the releases, download the one for 64 or 32. If you're not sure, just type uname. Just type uname-a, and if you see 64, if you see I386, 686, I mean, then it's 32. If you see this, it's 64. So, and for LinPeas, you can do the same thing. LinPeas, GitHub. It's this one by Carlos Pop. Go to the releases. There's one for Windows, Linux. You can just download the bash script into your system. So first thing is, I'm going to copy that tool. I have it already in my op directory here. We're also going to copy LinPeas here, and I'm going to go ahead and what's the IP address? There you go. Copy. I want to transfer both of these tools into the temp directory with using SCP, which works just like SSH, but it's for transferring files. And then I'm going to do the same thing with LinPeas. I'll run LinPeas later. And the reason why I want to run LinPeas is because you'll see that this machine can be pretty straightforward, but you can also easily get lost through false positives. Then we're going to do this. There we go. And let's see. So first things first, we go to our temp directory. Then even another basic check to see if we have anything on our home directory. We don't. So now let's go to the temp directory. You'll see the two there. I'm going to run LinPeas first. Pspy first. So what Pspy does is it pretty much checks all running processes by all users and who executed them. Usually 1000, that's a user. Right now it's us. Okay, so we see some kind of service. This looks like an SSH connection, not ours. Looks like they connect a second later. Yep. PTS, that's an SSH connection. Starts at 0, so we're probably 0. And then we have this command right here. Sudo cat etc shadow. And the process starts by root. You see that? And see, there's it. There's the SSH. So it looks like there's an SSH connection, then they exit and run this command. The UI effective ID of 0 is root. You could check the etc passwd file. 1000 is ours. So if you do passwd, right, 1000, that's ours right here. Frank, 0 is root. So if we had 0, we would be sort of the root user. But before I clear that, so this could be misleading. You may be thinking root is executing this because it's 0, but no, the process is running as root. But since Frank is executing the command, is logging in, and Frank is, you can assume that Frank is running sudo cat etc shadow. We're part of the sudo group. It happens right after the connection, and it is very, very rare. You don't see a root user using sudo because the point of sudo is to execute as the root user. So that looks like the way to do this. What I'm gonna do is I'm going to exit. Copy this command, and I'm gonna create a new window, SSH LinPeas, and I'm going to do this. I'm gonna log in again. So I'm gonna go to temp and going to do bash LinPeas.sh. I usually save it to a file and then transfer the file out, but I'm going to let this kind of run, and we'll go over it a bit later. But now let's focus on Pspy. So what can we do? The one thing, if you noticed, was that the sudo command was being executed like this, right? Sudo cat etc shadow. Let's see. Whoops. Shadow. Right. As for a password, we don't know it. Anything sudo will ask for a password. You know. So we could try another command that works. Is this cat etc shadow. And that's because this is where sudo is located, which tells you where sudo is located. So both of these work. The way the Linux system works, it looks at this variable. Every Linux system has this called path. The path is the path that it looks at to find the variable. So in this machine, every path will be different. But in this machine, for example, it looks at sbin first, user local sbin. Then it looks at user local bin. Then it looks at user sbin, user bin, and so on. So for sudo, whenever I use sudo without the path selected, it will go through every single one until it finds it, which will be here, right? If I can write in any of these before it, or even you can actually modify the path, which we'll show later. You can create your own directory and write your own sudo command, and that when this one gets executed without the full path, it will execute that one first, which will be ours. But how can we control like the sudo command that, even though it's Frank doing it, how can we control the SSH connection? Well, that's when sudo hijacking comes in. And if you want to see a little bit of how PATH hijacking works, we could do it this way. So for example, I'm going to create a, let's see, oh yeah, let me create a, you know the cat command, right? Cat idrsa read files. I want to create my own. Call it echo hi. We're going to make it executable. This is PATH hijacking, which ties into sudo hijacking. So if I do cat idrsa, I still read the file. If I select my executable, it says just hi, right? Now, and that's because if I do which cat, that's where my cat is, and it is right here. So what if I do wd, what if I do this? What if I do export path equals, so I'm going to change the variable. I'm going to add this colon and the variable path. So this will add this at the very front. And if we do it again, now it's going to look at here first, right? So if I do cat idrsa echo hi, let me go back one. If I do it again, actually I'll try to read Eavesdropper idrsa, I still get hi, right? So that's kind of funny. If I do user bin cat Eavesdropper, now it works. Oh no, idrsa. Now I can read it. So that's pretty much how that works. If I remove this and I do cat Eavesdropper, if I remove that command and I do this, then it goes back to the default because there is no cat here. So it goes, looks at the other one, right? So that's what we're going to try to do. But how can we don't have any write access to these. We don't, right? If we could just have write access, we could change that command. Well, because we know that there's an SSH connection, our new terminal loads. And when that happens, look at this, sudo hijacking, I think it's sudo hijacking hack tricks. Here, come on, there is it. I know it's here somewhere. Sudo, there we go. So, get that a bit bigger. If you know that a user connects to a machine and uses sudo, that sounds like our scenario, to escalate privileges, and you got to show within that user context. Yeah, we're Frank. You can create a new sudo executable, and you can modify the path to execute your code as root and then the user's command. But we have to modify the path. Any of these files, this is a CSH file, bash profile. So this one is actually the one on our system. Minimize that. So if we look at that, we see where'd it go? Bash RC, right? So what we have to do is, first let's create our executable. vi temp sudo. Now what happens, actually before we do that, what happens if we do sudo command? That's for a password. We can make this a bit realistic. Let's see. Ask for input Linux. We could do that. We could do this one. Read, yeah, okay. Read SP. Like this. Let's copy this whole thing. So we're going to do vi temp sudo. I'm going to do copy that in bash, delete that, actually delete this. So we're gonna read and let's see, where to go? There, copy that. And we're going to do that. We leave it, you can leave it as passbar, you could call it password. Then we're gonna do echo password home frank password dot text there. So this is gonna ask for the prompt. Whoever executes this is gonna type it in, and then it's going to, then we're gonna echo that variable, whatever they typed in, to this file. Right? So if we do bash perfect. So we have our hijack there, and remove that. What we have to do now is make it executable. There. So let's see if we can, this is just like a particular thing. I think I can do a line break, echo that. Can I do that? Yeah, there you go. So we have our malicious executable. Now we have to go ahead and do that. So let me exit here. I want to have a third connection ready. Let's see. Do it here. SSH path check. Right? So do echo path up there. So let's do that. So I'm going to copy this path here, right? And we know we have to edit this. Now, the tricky thing is, if we put it at the bottom, this is just a good lesson, because with any script, a lot of times it'll go through, and there's a lot of if statements here, right? A lot of if statements. So sometimes putting it at the bottom would work, because it'll go through everything, and then you'll execute yours last. But actually, a lot of times it is better to put it at the very top. I find if it doesn't work at the top, then I'll look into it. But put it at the bottom and it won't execute, you can start thinking this is not the way. Especially if not run it interactively, don't do anything. And then, so you want it here, you're going to do path, colon, and now you want to add the path. So now, I'm going to save that. This won't change your current terminal, right? See, it's still the same. But it will change this one. So if we do path here, there we go, right? So whoever logs in, if Frank logs in every time from now on, you'll have, oh, and we have a password file. We didn't exit, I removed it before. And that's definitely not what I typed before. We have a password. Now, of course, if we tried here, sudo su, it's not gonna happen because oh well, look at that, that's not right. Because of we hijacked our own path. You could just remove it, sign in again, or we could just do our original terminal, because this one is now hijacked. So now, because we're part of the sudo group, we do sudo su. There we go. I believe we could pretty much run anything. Sudo-l, right? You could do sudo bash. It'll work. It won't ask you to press for every time, just the first time. And we are the root user, right? And pretty much does the challenge. You go capture the flag. I believe it's in the root directory, right? You capture that and submit it. But for now, take a little detour and look at LinPeas. Because LinPeas does sometimes try to point out things like, is this vulnerable to this? And if we look this up, exploit, right? So, what's this? Yeah, let's see, it's a bug, the exponential file credentials. So this is pretty more or less recent, just a little last year ago, but this is a post positive because it's exploit in C, and right away we can discard it because we don't have GCC. We don't have a good way to compile it. What else? LinPeas. That's all it tells us. It tells us all these other things. It's also C. So right off the bat, C wouldn't work. It doesn't even advise release agent breakout. That's interesting. Let's see. Captac override. Right? So there is so if you run LinPeas, it might try to point things out, but right away you have to figure out what is a false positive. Like those CVEs, easy to focus on those. It's not working. You're like, oh, okay, what do I do? But if you notice, LinPeas doesn't point this out, the actual path to us. That was really just Pspy and us understanding how it works. This is a Docker environment, so we're in a Docker. So, maybe there's a way, not now in the future, to escape out of this Docker environment. But that will be, if you could do that, that'd be great. That's out of this room scope. But anyway, that's the challenge. Feel free to comment, like, and subscribe, and I'll see you all next time.